Hey everybody, welcome back. So we are talking about the nervous system. We're talking about the brain. I am Elisa, and we are going to just kind of get in a little bit more to the brain stem, the midbrain, the pons, and medulla oblongata. Sorry, gosh, that is a tongue twister. Medulla oblongata. You should use that as your password. Yeah, that's a good one. All right, let's take a look at this brain stem. So the brainstem properly is all three of these regions, like we just talked about. Um, so these actually start off as like a lot, like a high percentage of the developing brain, and then what ends up happening is other parts of the brain, like diencephalon and telencephalon, just start really taking over, and they take over so much they actually kind of like come over on the sides of the brain itself, right? So these are specialized regions which we've been able to identify, and they have some shapes that have, differentiate them, but really a lot of what we, kind of care about them is their processing is pretty is divided, largely, not entirely, but largely. So they're similar in structure to the spinal cord, like we just said, obviously. There it is. But it contains nuclei, meaning a little bit of gray matter in the white matter. Like a little bit of gray. Little bit of gray matter. God, I try to get things that are typed for you. So sorry. Okay, anyway. So what this does is this is like the most basic part of your brain, and we would think of this as like the worm brain is what I've heard of a lot. And so it's a conserved set of functions between like all animals, whether they be like 300, you know, count cell big worms, which we are still 50% related to. Just chew on that, but probably not with your medulla oblongata because that's not really where you would process it. But anyway. So it controls things like your more automatic behaviors, like there's light, swim towards, or it's cold, swim away, or I think there's food over here, swim towards, right? Very basic stuff for survival. We'll talk about a few what items of what those things are. So you're not really processing any higher order functions, right? You're not deciding what you're going to wear that day. You're not doing your calculus homework this way. It's just some like heart rate level stuff, like are you breathing, are you throwing up right now, like that kind of stuff. So they can train a lot of these neural fiber tracks. Whenever we think of fiber, think white matter, right? That's what they are. They're really super highways for the business that's going on in the brain and the business that's going out there in the body. So that's a lot of what they kind of do. So the nuclei, right, or the gray matter inside is directly associated with the most of the cranial nerves, right? Because they're in the cranium, right? So they just kind of are going to radiate out primarily from the cranium. So here's kind of here's a little bit of what to look for. So here's the spinal cord proper, right? So here it comes. And spinal cord proper, like as soon as it starts to get a little bit like thicker, is where we start dividing it into like this would be like medulla oblongata right here. Pons is nice divider because the pons has a bit of a belly to it, which is like a nice thing, right? So medulla oblongata is where it expands, right? So there's expansion there. Spinal cord itself is going to be like, the same all the way down through the spine until we get to cauda equina. And then the midbrain is kind of like insular, if you will. So insula means like inside. So it's going to be, if you were to take these like lobes off, you'd get a better look at it. But for the most part, it's not terribly different structurally. And see here's longitudinal fissures. You can see going back to the idea of bilateral symmetry is still somewhat present in all of these structures. All right. So other things just to kind of bring up is, I don't know, let me just erase this. This is going to be more helpful if I erase it. Because then there they are. Hello. Hi, guys. So see these structures, right? I'm going to just kind of highlight them on the one side, and you can see the analogous structures on the other side, right? These are going to be some of our cranial nerves right here. right, that we'll look at in other videos. So see, when they mean they're associated closely with them, they are associated closely with them, right? They're sitting on them, they're radiating from them. Okay, so the midbrain. Vision, hearing, motor control. It also can control some of the sleep-wake cycle, and the arousal, the how awake and paying attention are you part of the cycle. It also, again, basic stuff like temperature regulation. Okay, so the pons is located between midbrain and medulla oblongata. Pons, right? And so it has going to have a lot of longitudinal fibers, right? Because remember, we have that brain, and here's, all the, there's a lot of business up there. Here's the brain. And then here's like midbrain area, a little belly on that pons, which is how we, like, it's easiest to dissect it, find that, and then we go into brainstem proper, right? So it's connecting a lot of this, the work that needs to be done here, in the rest of the brain. So it's helpful for processing. So also it does something kind of interesting. So it sits, like, if you remember cerebellum, which is a very, very smart part of your brain that really, does a lot of higher order processing, and you're never allowed to actually access cerebellum while you're conscious, right? So it's not part of that. So it runs relay between that and the rest of your brain, right? And, some of the other things, it helps maintain your breathing relatively normal. Humans can control their breathing, which is kind of interesting. Not all animals can do that, but when you don't want to be thinking about breathing in and breathing out, thank you, Pons, for that. Just handling it. Okay, medulla oblongata. Hold on. Oblongata. Oops, sorry. It's supposed to have more of a tail on that A. Okay, medulla oblongata. So we talked about it blending into the spinal cord, and that happens right at foramen magnum, and that's because foramen magnum is only one size, and so if medulla oblongata is going to be bigger on one side, like the smaller part of the brainstem is going to be what fits through, and so that's kind of the limiting step. It contains this really interesting, like, membrane, which is the choroid plexus, and it's capillary rich because it's, doing a lot with, like, the filtration and replacement of cerebral spinal fluid, which is this awesome it's a very watery, semi-viscous substance that we bathe the brain, the brainstem, the central nervous system in, since we have that blood-brain barrier. So choroid plexus is going to be essential for actually making that cerebral spinal fluid, filtering it out, making the new stuff. If not, if we just if we didn't constantly filter this cerebral spinal fluid and turn it over, our brains would be sitting in a big bathtub of their old used neurotransmitters, and you would not be able to get a reasonable or clear thought across, right? A lot of the activity that choroid plexus is we're learning, is associated with the sleep function. So, as we learn more and more about what sleep is, yeah, you're resting your body, but really, like, what are you doing? Like, how is that? Right? And it teaches us a lot about, like, the freshest times of the day for your brain, the best times for processing, and also a little bit about the worst and why we need sleep so much and why naps are awesome. Right? So anyway, so also the vestibular cochlear nuclei. So what these are doing is they're mediating equilibrium. So cochlear, right? So we're dealing with the ear, vestibule, all together. Nucleus cunatus and nucleus gracialis. So what these are doing is they're dealing with more sensory information processing and transfer from the spinal cord. Some more functions of medulla oblongata. This, like, strangely not super differentiated structure from the spinal cord, other than it's a little thicker. It's really stinking important. Like, this sucker is your autonomic reflex center, right? So it helps with that super fast flash processing. When you don't have time to, if you put your hand, like, here's, like, there's, like, a hot plate down here. I don't know. You were camping, you brought your hot plate, and there it is. And oh my gosh, it's so hot. It's so hot. Right? And you're, like, hanging out, and you're talking to your friend or whoever, or somebody, and you're just like, this is great. Don't you love this? I do love this. I'm going to lean here. Ah, hot plate. Right? One of the things that's going to tell us immediately to, I don't know if you've ever noticed this, but you never put your hand on the hot plate and go like, huh, my hand is hot. Ooh, ow. I should really move that or else I'm going to burn my hand. Okay, I'll do that. And then you move your hand away from the hot plate, right? So that's not really how that tends to go ever, really, because that's really where the reflex parts step in. So let me get you back in here. Okay, here you are, having a happy time again. There you are. Hi. Ooh, it's, I guess, a leg now. Everybody gets legs now. Okay, so now what ends up happening actually is like you put your hand on there, and before you even realize it's hot, you've withdrawn your hand, right? You've taken it back, right? And so that's reflex. That's kind of what it is. It's like these decisions that are made without you really being part of that equation. And they're done in the quicker, more rapid processing parts of your medulla, right? So it's trying to make it like right at the base of foramen magnum. A lot of the hypothalamic functions are going to overlap. So the medulla and hypothalamus have become really good neighbors, right? So lots of rerouting, lots of quick emotional sensory kind of exchanges, help understand more regulation in the body that needs to happen, quick decisions. Here, let's do this. You're feeling better now, right? Just stay away from that hot plate, okay? You. There you go. Just get back to camping. Have a good time. All right. So more functional groups of the medulla is like cardiovascular center. So it's nice because it's so close. We'll do this guy. It's so close to the heart, right? And so we're able to have that sensory exchange right away. And so we're able to keep homeostasis much more effectively, right? Just because of proximity altogether. And adjust a couple of things, actually more than that, but force and heart rate as well. The vasomotor center adjusts the blood vessel diameter, right? So that also is going to help for blood pressure, for example, blood pressure regulation. So medulla is doing a lot of business that you don't even think about, which is the point of it, to do it without you thinking about it. Okay, other things that medulla oblongata are working with is we're doing heart, but we're also doing respiratory centers. The respiratory system's we're getting there. So as you may know already, or actually you might be in the second class, you'll find second semester anatomy. Heart, really good stuff. It's actually, got some regular stimulation already, right? So atrioventricular nerve-like signaling from sinoatrial type centers. However, respiratory centers are solely stuck in the brain. It has no auto-regulation whatsoever. Right, you may have the equivalent of a cat brain of neurons in your gut for processing because it's so old, but your respiratory system is relatively new. It's still kind of probably arguably developing, evolutionarily speaking. So we are totally dependent on medulla oblongata just to keep that respiratory rhythm, to control the rate and how much we're breathing in, right? We use these pontine centers, which we'll look at a little bit later on. Some other centers that are kind of related are going to be the sneezing, coughing, swallowing, hiccuping. Oh, finally, right? Everyone's so thrilled about that one. And vomiting as well. Actually, also vomiting. Okay, so that's a look at our midbrain group right here on our Pons. Let's get the Medulla Oblongata. There it is. Right, brainstem before it becomes spinal cord. So we looked at Medulla Oblongata. It's got a lot of business going on for being not as big as we thought it was. Pons as well, talking to multiple parts of the brain, making some decisions, mainly talking to other parts of the brain. And then the midbrain as well, looking at a lot of emotions, kind of helping with those quick reactivity, as well as processing. So I hope this was helpful. I hope you feel a little more oriented, and I hope you are having a lovely afternoon. Goodbye.